Your team is building a microservices architecture hosted on Google Kubernetes Engine. During the testing phase, you need to verify how your application handles a scenario where one specific microservice stops functioning abruptly. Which approach should you take to simulate this condition? Option A. Apply a taint to a cluster node and set pod anti-affinity in the microservice deployment to match that node. Option B. Utilize Istio fault injection to mimic the failure of the designated microservice. Option C. Terminate a node within the Kubernetes cluster to witness how the system reacts. Option D. Modify Istio traffic routing rules to redirect requests away from the problematic microservice. Okay, so the correct answer here is option B. Utilize Istio fault injection to mimic the failure of the designated microservice. Istio fault injection allows us to control the introduction of faults, for instance, delays or error codes, and monitor how applications react to these simulations. This is a great way to evaluate the handling of fault tolerance and resilience in microservices. Now, let's take a look at the other options. Option A, applying a taint and utilizing pod anti-affinity, is not really the proper approach to simulate failures. Tainting can be used to restrict pod deployment, but it can't really simulate a failed service in the API requests. Option C, terminating a node, is a much more destructive approach. It would reveal how the cluster rebalances pods, but it wouldn't introduce a virtual failure within the API network. And option D, modifying Istio traffic routing rules, is a beneficial technique, but it's...
When running complex microservices on Kubernetes, ensuring application resilience against component failures is critical. We often need to test how upstream services react when a downstream dependency suddenly fails or returns errors, without actually destroying underlying infrastructure or making permanent routing changes.
In my view, the correct answer is option B. Istio's fault injection feature is specifically designed for testing the resilience of microservices by allowing you to simulate failures, such as service aborts or latency injections. This approach provides a controlled environment to observe how the rest of the application handles a crashing or failing microservice without needing to disrupt underlying infrastructure.
As for the other options, option A describes scheduling constraints, not a simulation of service failure. Option C is a crude method that disrupts the entire node rather than testing a specific service, potentially causing unintended side effects for other services. Finally, option D describes a traffic management configuration to mitigate failures, not the mechanism used to simulate the crash in the first place.